So we're back into Python to consider regular expressions within this context. We're using the Jupyter Notebook at this point on my own machine, but you could just as easily be using Google Colab for this, or using the ASU cluster or somewhere else to kind of use this, as long as it's working, as long as it's a working copy of Python. So I start by importing RE for regular expressions. I also import the URL open method from URL lib request, which we've done before way back in the first module, if you can think back that far. And here all I'm doing is opening and reading this site, the Wikipedia site for Tycho Brahe, reading all of that in. And then if you look here, once I've read it in, I'm making it into a string, because by default it's going to bring it in as bytecode, but we want to switch it over to a string. So we have one string here. Let's run that and make sure that we have something coming in. I've called the variable Tycho, and if I run that, I get this blob of, and of course it's bringing it in as HTML, so it's this very large blob of HTML, right? Very large. There may be somewhere in here some sentences, but it's hard to find them because there's kind of such a mess, right? So what can we do with this? Well, let's say we wanted to find out if Brahe is actually mentioned in this. We could do that without ever having to worry about regular expressions, just by running a search for find for Brahe as a regular string method that's built in and everything, and it'll tell us that yes, he shows up at 113. So you know, if we wanted to, we could go ahead and do take a look at this, a slice of it. Tycho is the file, and we want to take a slice from 113. Brahe is 5, so from 113 to 118, and we'll get Brahe. That's great. Now I suspect there's more than one mention of that in there, and so there's a number of ways we could kind of get at the more than a single mention. We could, for example, go for the regular expression. Well, first let's start with doing the same thing we've done with find, but using the regular expression search function. Okay, so we can search for Brahe within Tycho. This is the way we kind of do it here. We run it as a function, research for Brahe with Tycho, and we run that, and it's going to come back with a match object. We could have saved this, you know, kind of saying m equals, right, or match equals, and it tells us, it produces not a single answer, but it gives us an object with a span and what it is that's matched. Of course, it's matched that. We ran through this when we were dealing with regex in the other context, that, you know, we're getting an exact match. So we don't really need to know what the match is, because we know that's what we're looking for. But this gives us that span. It still is only getting one of the Brahes, though, and I know that there's going to be more than one of those. I almost never use RE search. What I normally would use is RE find all. I use RE find all whenever I'm using regular expressions. That's generally what I'm going to use. Now, the output from find all is not an object, it's a list. It's a list of all the things that it's found. And it's found Brahe lots and lots of times in this document, right? But it doesn't tell us anything about it. Now, again, for what I'm doing, for example, if we were going back to grep and I'm extracting, say, phone numbers from a very long list, or finding out how often a particular person is mentioned, then this is fine. I'm just getting the actual hits. But that's not really what I was looking for. There is a way that I almost never use called find iter. And if I run that, what it says is that this is going to create an iterator. So really what we need to do, we'll call this match. So we'll match it, and then we have to go through this iterator. There's a bunch of ways we could do that. I'm going to do it kind of normally you do it in a little bit quicker way, but we'll just say for each one in the match, go ahead and print the match that we have. Oops, that's 4. Sorry. In. So now we have a list of match objects, just like we'd done the search. We've got that first one, but then we know where the rest of them are, and we could go through and do whatever we wanted to do, change Brahe's name to something else. Actually, there's a way to do that using re.sub, but there's a bunch of things we could do here to make that work. Yeah, I don't want to change his name right now. Yeah, we could. Well, we could. Let's. Well, we'll worry about that in a minute. Just to let you know, the way we would do it if we wanted to is we would go re sub. Well, we could do this actually using just a string replace. We could do tycho.replace and then do Brahe and change him to Brohim or something, you know. So we could go ahead and do that, but we don't need to. Let's go back to find all, which is what we were doing in the first place and the thing that we do much more of. And again, we generally aren't looking for one thing. Let's go back to what we were doing before and see if we can find all of the proper nouns. And so proper nouns are starting with a capital letter, right? Like so from A to Z, followed by one or more lowercase letters. So one or more we were using star before, we get just initials there. Let's go ahead and use plus, which is we need at least one of these single letters, and we can have any more of them that are single lowercase letters as well. So if we run that, we get all of these words that show up as capitalized words throughout the piece. If we were looking for the double capital, we would just put in a space between the two, right? So we could just do Tycho Brahe, Our Lady, Old Town, right? Prague Astronomical, Galileo Galilei. So this is getting us all of these double words, which we'll get a bunch of names obviously here, but it's also getting some other random stuff, right? That are not people's names. So ancient Greek. So that gets us something though. It starts to get us towards those noun phrases. What if we wanted to find out, say? So I'm going to introduce something here, which is instead of this character, we can use a \W. Now here's where we start to get a little bit tricky. So within regular expressions, we ran into this before, like the \D is for a digit, \W is any word like character. So this could be uppercase or lowercase. The nice thing about this is this particular, I mean, we don't need to talk about kind of the details of debugging these things, but if someone's name was, say, McPherson or McSally or whatever, it wouldn't catch it, right? Because it would be an uppercase, lowercase, lowercase, right? And so that doesn't actually fit this pattern. This is any kind of word-like letter, right? So if we replace it with that and replace it with that, actually, let's just do that first so we can see what we get. Oh, it's working. I wasn't expecting it to work. The reason I wasn't expecting it to work is that these can cause us a problem because the backslashes are registered as backslashes by the system itself. And so often when you have this, you need to put an R in front of here, which is raw. And that means basically if I put a \n in there, it will look for the \n rather than looking for the return. Let's make sure that will work now that I've told you that that's what we're doing. Yeah, that does work. But normally you would need to do that. I'm not quite sure why it worked before. I was expecting it to fail. But generally speaking, when you're putting together these regular expressions, if you know you're going to be using any backslashed things in the middle of it, you need to put the R for raw in front of it. Part of that is because you know, if I were looking for not this, but something with a word with a plus in it, you know, you actually have to escape the plus, you know, in the regular expression itself. So it wouldn't read it because it gets confused when you're using the backslash as an escape character for both the Python and for the regex. it can get very easily confusing. What you'd actually have to do for, like, you'd have to, if you're looking for backslashes, for example, you'd have to do backslash, 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 because you'd have to escape out of the backslashes to put them into the string, and then you'd have to escape out of those backslashes to put them in the regex, and so it just gets super confusing. So you just put an R in the front of it, and that says, for this string, don't consider backslash t to be a tab, consider it to be a backslash tab t. I know that's a little confusing, but nothing more than what's already confusing in regexes more generally. What if we wanted to know, like, what, so we have some ways of getting words here. We could actually just do this, and that will get us pairs of words, right? But let's, you know what we could do is we could do, well, let's just do this. We have got a word and a word. Let's put brahe in here and see what we get when we look at this. What this says is look for some letters with a word, a space, and letters with a word, and that means we should get the two words around brahe. Let's see if that actually works. Tycho Brahe signature, Tycho Brahe framed, Tycho Brahe was, Thige Brahe was. So that seems to be working pretty well. We're probably missing some here where brahe is the first word in the sentence, because if there's a period in here, it won't work. Here, let's add in some more words so we're getting a few around each side, right? So if we run that one, which has a bunch of them around, actually it's much shorter here, because we kind of are blocking this out because it requires that you have this many words before and this many words after. What we could do is say we're okay if there's a period, right? In this case, it's an actual period because it's not. So this case, what a period matches is anything, right? And so we don't want it to match anything. We want it to actually match a period. So this is another one of those cases where, because a period is like the wild card for any single letter in regex. And again, I certainly don't remember all of these things, but I'll put a cheat sheet up there, and you'll probably have to think about these. So because of that, we need to have a backslash period to say we're actually looking for periods here. And then what we're going to say is it doesn't have to be there. We're going to put a question mark. And what that means is it can be there or not. Either way matches. And so what we're going to say is that after any one of these words, before or after, we can have we're fine with a period, right? And same for the after. Actually, we should say we're okay for a period there too. So there could be a period right after brahe, right? And then, or not. Either way is fine. And then any of these could also have a period in them. And this, as you can imagine, will only work for periods. So if someone answers ends their sentence with a question mark, or there's a question mark anywhere in here, or a dash anywhere in here, or a semicolon, or even a comma, it won't actually match. So this could get more and more complicated as we added in potential things that we might want to match. This one didn't match anything at all. Oh, that's no fun. Hold on. Okay, so I'll have to think about why that might be. So this one has the periods. It must be just having a problem with the backslash period right after. So, but here we have an example of one that does match. So the history of the Tycho Brahe family period. So that period before would have excluded it without having included the possibility of periods after any of these. We could also put in the possibility of commas or the possibility of these other things. So it gets complicated to match that. Just a quick reminder of what this text we're working with looks like. Looks a bit like this. And so it's a mess. I'm going to back up for just a second and just note, what if we just wanted to know the words that come in a sentence after brahe? There is the possibility of putting parentheses around some of these to kind of know. Let's do the ones directly before and directly after. So we can do this and put parentheses around these to group these. So for example, if you were looking for phone numbers and you wanted to bracket out and figure out what the area codes were or something like that, you could actually specify what part of it you're trying to capture. So Tycho Tycho Brahe framed, or Dige Brahe was. So there's a way to kind of grab pieces of this using these parentheses and say, these are the bits of the match that I'm trying to get. So one of the ways we might think about doing that is, let's say we were looking for, well, we've seen what it looks like. It's a bunch of HTML. Now, later on in a module, we're going to look at some tools that will allow us to parse through that HTML and figure out what's what there and how things are labeled and a bunch of other stuff and make it easier to navigate all that. But let's say we were just looking for a collection of words, right? We don't really care about the format in any way at all, and we just need a really rough cut of that. What would we do? Well, if you remember how HTML works, it's tagged by having, here's the A tag, for example. It's tagged by having things surrounded by these, right? So what if you only looked at the stuff that was inside the sort of, this is inside these, right? This tag is made up of this and this, right? What if you only looked at things that were inside this and this and didn't include any other tag bits? I wonder what that would look like. So let's figure that out. So what we want is we want to look through this, and we want to find all of the occurrences where it starts from here and it doesn't end until you get to here. And so the way we're going to do that is we're fine with anything that comes in between these two. So how would we say that? Anything would be like this, right? Actually, we could do anything by going like just this. Anything until you get to here, right? So that we could say it that way. I don't think that will quite work because it's missing the string that we're looking for. And that's not quite doing what we want it to do at all, because it's not catching those. And the trick is it's having trouble with this bit here, because it's going to accept all of those, including this. And so that's not really what we want. We want it to include everything except for if it runs into that second caret, right? So what we want is caret is the wrong word because that's the caret. We want everything except that. So that's kind of the not sign. So what will fit in there is any character that's not the greater than sign, the beginning of a new tag. So let's try that and see what that looks like when we run it. So this is getting pretty close, right? Some of this is escaped text. Some of it's other things, but this is starting to look a lot like it's capturing the actual text of the piece. Now, there are a couple of issues here. One is that it's also capturing, of course, that open caret because because it's in the regex up here. And we know now, because I just touched on it, how we get rid of that. We just select the part that we want to save, which is this part here. So let's do that and see if it fixes things a little bit. Now it's starting to look like a bit like that, right? Now, of course, it's in a bunch of collections here, but we have what looks like, there's some here that, no, that's true. That's text. It just has some stuff in it. In some places, we don't have any text in between. But generally speaking, it looks like it's pulling out all the stuff that's not inside of tags, which is a bit of what we were looking for. We could put this is a long list of strings, right? And so we could put that in its own variable, make it a long list of strings. And then once we've done that, we can do, I don't know that we've hit this before, we can do a join. So what I'm going to do is I'm just going to do a space and then say join match. So the join method can be applied to a string, and what it says is take this string and put it between everything in this list, in the match list. So all we're doing is we had a list before, and now we've created a string, and the string is all the stuff we had in the list tied together with spaces. So we've just taken that list and kind of pushed it all together, but used spaces between them. We could have done returns and stuff, or new lines, but it was already kind of new lined out. This is just one huge collection of stuff, right? Now we've got the double ends are tricky because of the way it's done it, but let's do this. We'll put all of that into match. So match turns from being, in this case, a list, and now we're just kind of erasing it and making it into a string. So we now have that as a string, as match. And let's go ahead and match. We could do as I said before, there is the sub, the method in regular expressions for sub, but for now, I'm just going to replace some of those new line ends, the new line symbols, with a whole bunch of nothing. And let's see if that cleans things up a little bit. It's not getting those double ends. Those may actually be raw double ends. So let's try that. There we go. So this one, before it wasn't getting them because they weren't actually new lines, they were backslashes. But this one gets it by pulling out, by looking for a raw \n and pulling that out, and it manages to do it. So now we're getting closer and closer. We've got these in here. We could look for basically any remaining backslashed somethings. We'd have to we could do a regex for that because it looks like there's a bunch of these that are non-printable characters or printable characters, but that have come over from Unicode in that way. And we also have some backslashes that are attempting to backslash out the quote marks, which is not surprising. So we've got a bunch here that we would need to still clean up a bit more, but we could actually, let's do this. You know, if we were trying to do at this point something like a word count, we could do that, and then we could do an RE find all, and we could just look for every word. And so that's relatively straightforward. We know what the symbol for the word is. It's just W, and we need at least one letter to make it into a word. And we could look for all of those inside of match, and we would end up with a list of, we're hitting some nothings, but we'd end up with a list of we could do this. We don't want nothing, so we'll change it into a plus, right? Oops. It shouldn't actually be matching that, but sorry about that. Plus. But that kind of takes care of the ones that are non. And so then we end up with a list of words, kind of a whole big list of words that we could kind of use to think about if we wanted to make a map of those words. We're going to spend a whole bunch of time on dealing with how we deal with text and make sense of text. But as a very quick and dirty way to do it, we can use we have very few lines of code here to use regular expressions to come up with that. Now again, how often do you use regular expressions? Not super often, to be honest, but there are times when they can save you a whole lot of hassle. Even though they themselves are a hassle, they can kind of make short work of some of these small tasks and kind of pull things out and arrange them in various ways. I don't usually use that at the command line because I don't need to. I can kind of open up Python and do it here. And since Python is my kind of go-to for a lot of this stuff, it makes sense to kind of concentrate on that and make use of the tools within Python itself. If you have to, you can kind of now that you've used grep, you could not, and maybe if you didn't have access to Python for some reason or something, how could you possibly not have access? You would be able to use that. But generally speaking, we use them in regex, in Python, and I will say that there is never a time when I mean I remember some of these, but there's never a time when I don't want to pull up a set of shortcuts or a guide or a cheat sheet that will tell me what each of the little pieces are. And there's never a time when I get it the first time, right? I have to experiment with a little bit and try to figure out if my pattern for regex will actually match all the things I want it to, or most of the things I want it to. And so it's a little bit of playing around with it to see, again, it's a bit like a puzzle, to see how to puzzle out what matches what. So I think we'll leave it there for regex and move on to another tool for your tool set.